With our changing nonce value for the block, we have implemented a proof of work system where miners must spend a bit of computational power to add blocks to the chain. However, as more and more peers are added to this blockchain network, blocks will start to be discovered at a faster rate, as there will be a higher chance for at least one miner to discover a valid hash at the set difficulty. Therefore, we need a dynamic system that adjusts a blockchain's difficulty level as more miners are added to the system. To achieve this, we can add a difficulty attribute to each block. In addition, we'll also set a time value called mine rate, which represents the rate at which we want each block to be mined. The difficulty adjustment mechanism will work like this. We'll check the timestamp of the newly mined block and compare it to the timestamp of the previously mined block. If the difference between both timestamps is lower than our mine rate, then we know that the block was mined too difficultly. Therefore, we'll raise the difficulty by 1. Likewise, if the difference in timestamps between our newest block and the block that came before it is bigger than our mine rate, we know that the block was mined too slowly. Therefore, we'll lower the difficulty by 1. With this system, we'll always adjust the difficulty for each new block, and we should have a system that mines blocks at a set interval through our mine rate. Alright, let's implement this system in our code, so go ahead and switch to your code editor. To incorporate this dynamic difficulty mechanism, first we'll define the mining rate for our blocks. Every 3 seconds isn't too long, but long enough to check the dynamic difficulty mechanism is actually working when we actually test it out. So let's create a new constant called mine rate, and then we'll set it to 3000, which is representative of 3 seconds, since this mine rate value is actually in milliseconds. Then let's make sure this mine rate constant is shared alongside the difficulty constant in the module exports object. So place it right alongside and just write it once in the module.exports object. Now we'll include the mine rate constant alongside the other difficulty constant within our block.js file. So right next to difficulty, let's also include the mine rate. Next, we'll add difficulty attributes to each block in the chain. Rather than relying on the statically declared difficulty constant in our configuration file, each new block will base its difficulty based on calculating its difference in timestamps to the last block in the chain. So let's add a new parameter to our block constructor, difficulty. And then we'll also bind a difficulty attribute to an instance of this block. So this dot difficulty equals the inputted difficulty. And there's one thing to consider though. If the difficulty of each block will be based on adjusting the difficulty of the block that came before it, well, what about the first block in our chain? For the first block, we'll set its difficulty to the given difficulty of the system. That way we can have at least something to start with. So we'll have an OR statement over here that is OR the regular difficulty given by the configuration file if there's nothing specified in the constructor. With this new attribute, let's update our hash functions to include that difficulty. So scrolling down, our hash function should take a difficulty parameter now. Likewise, we'll include the difficulty in the calculation of our actual SHA-256 hash string. In our block hash, we'll want to grab the difficulty from the incoming block and then also use that as we return block.hash to add difficulty as one of the parameters. Likewise, let's head to our toString function. After the nonce, let's also specify the difficulty. So now we're going to need to put a space after each one of our other values in order to keep the colons aligned. And then we'll insert this dot difficulty in a pair of $ and curly braces. Finally, in our Genesis block, we need to give it a starting difficulty, so why not the difficulty configuration constant as the starting difficulty. Great. The difficulty of each block will be based on the difficulty of the block that came before it. So let's get access to the difficulty of the last block at the top of our mine block function. That way we can calculate the new difficulty for the next mine block based on this last difficulty. So we're going to grab their difficulty and assign it to our last block. So this is ES6 destruction syntax to declare a local difficulty variable that is assigned to the difficulty key that is within this last block object. Then we'll recalculate the difficulty at every iteration of our while loop. We'll be adjusting the difficulty based on the timestamp of the newly mined block. So we need to recalculate the difficulty at every iteration of this loop. So let's say difficulty equals right after timestamp and right before the hash. And we'll assign it to an adjust difficulty function that we'll create in just a moment. So let's call this block.adjustDifficulty. Now the first parameter is the last block, so that way it can access the timestamp and the difficulty of the block that came before it, as well as this timestamp over here, so that way it can know when this actual block was generated, so that way it can understand how to adjust that difficulty. Before we write this function, there's one last thing to consider. We'll have the adjusted difficulty for every new block in our chain. Therefore, rather than using the configuration difficulty, we're going to use the difficulty provided to us by the last block. So rather than the lowercase, or rather than the uppercase, we're going to use the lowercase difficulty defined locally. Likewise, we'll go up to the difficulty for our 0 string that is defined locally. Also, we need to calculate the hash for this block by also inputting the difficulty that is calculated as a result of this function, so that way our hash stays consistent. Finally, when we return our block, we'll also return the difficulty loaded in as the final parameter to our this function. All right, great. With all of that, we can finally add the new adjust difficulty function to this class. So let's make sure it's static because we're accessing it in a static way within our mindBlock function. So that's static adjust difficulty. The parameter is the last block, and then let's call the timestamp that is coming in the current time. Within this function, let's immediately grab the difficulty of the last block like we did so in the mindBlock function with let curly braces difficulty equals last block. And then we'll adjust the difficulty based on the timestamp of this last block in the timestamp we received as the current time. What we need to check is if the sum of the last block's timestamp plus a mine rate value is greater than the current time. If so, we know that the difficulty should be raised. After all, if our mine rate is 3000 milliseconds, but the timestamp of the last block occurred less than 3000 milliseconds ago, well, we know that the difficulty was too easy, so we need to raise it. Therefore, let's create a ternary expression that adjusts this difficulty. We'll say difficulty equals last block dot timestamp plus our mine rate constant, which is 3000, and we're going to ask if it's greater than current time, and then our question mark starts the ternary expression. So if so, we're going to set the current difficulty to difficulty plus 1, therefore raising the difficulty if our block was mined too quickly. In the other case, which we handle with a colon over here, well, the last block plus a mine rate is not greater than the current time. Then we know that the difficulty was too high since the newest block was mined too slowly. Therefore, we set difficulty to the current difficulty value minus 1. All right, finally, as a result, let's return the difficulty that we adjusted and calculated. Cool. That completes the adjust difficulty function. With that created, we've completed setting up the dynamic difficulty adjustment mechanism. Since every block that is now being mined in our system will adjust its difficulty based off the block that came before it, as well as its current timestamp. Let's make sure all of this functionality works in the way we intended to by writing some unit tests next around the adjust difficulty function and exploring its behavior with an additional script to experiment with this new difficulty mechanism.